In this video, we are going to perform hands-on with the open source Mixtral model in the free version of Google Colab. In one of our earlier videos, we performed hands-on with the smallish open source models like Dolly 3 billion model released by Databricks and Falcon 7 billion model released by Technology Innovation Institute UAE. However, Mixtral model has a whopping 47 billion parameter, and the sheer fact that we are able to run such a large model on a free version of Colab is a big deal. More parameters means a stronger model giving better results on your GenAI project or hands-on exploration. Now, before we jump into the hands-on part, let me first give you a super quick overview of how we are able to run the Mixtral model with 47 billion parameters on free Google Colab. If you want to skip to the hands-on part, you may do that as well. Mixtral 8x7 billion is a high-quality sparse mixture of experts model. This model not only outperforms Llama 2, which is a 70 billion parameter model on most benchmarks, it does so with 6 times faster inference. So for sure, it is one of the strongest open source models that are available to date. Now let's talk about how Mixtral is tailor-made to run on low compute environment like Colab that offers free T4 GPU that comes with 16 GB of GPU memory. Well, as a mixture of experts model, Mixtral's total model parameters are around 46.7 billion or 47 billion. Now, these parameters are divided into 8 distinct groups called experts, hence the name mixture of experts. And for every token, only 2 of these 8 groups or experts are called through our gating function to process the token. And once these experts are done processing a token, their outputs are combined additively. So as against a typical model like Llama 2 that will call all 70 billion parameters to process each token, Mixtral uses only a fraction of its parameters, and this is what makes it computationally efficient. For running the Mixtral model on Colab, we are going to follow this particular paper titled Fast Inference of a Mixture of Experts Language Models with Offloading. Let me explain the basic intuition from this paper real quick. We already know that Mixtral model is modular. It has 8 distinct set of experts, 2 of which are called for processing each token through a gating function. Gating function is like a traffic controller analyzing the user input and accordingly assigning the task to the most appropriate set of experts. So if you think about it, once the experts are selected and engaged for a task, remaining unengaged experts could be moved out or offloaded from the GPU memory, which is limited to a cheaper memory like system RAM or even SSD. Well, this offloading part is the central theme to this particular research paper, where it proposes a speculative expert loading algorithm, which is this. For more details on this, I'll strongly recommend you to go through this paper. Find a link to this in the description part below. Anyways, if you guys have any specific questions on this part, you may also post them in the comment section and we'll respond to those. Alright, now it's time to get our hands dirty and actually run Mixtral on Colab. Before we begin, let's set our house in order by setting up our Colab environment. First of all, let's change our runtime type to T4 GPU. I've already done that. Just ensure you have this selected, save it, and connect to a T4 runtime now. Now let's set up our environment to run Mixtral on Colab. Now let's talk about this first section, which is installing and importing. First up, we import the helper library NumPy. Next up, this part is primarily for setting up environment for running Mixtral with NVIDIA Triton Inference server on Google Colab, particularly when using a T4 GPU. Within this, we set a bunch of these environment variables, UTF-8 to ensure consistent character encoding and language processing, which is crucial for proper text handling, specifying directory containing NVIDIA libraries that are needed for GPU acceleration, and lastly, specifying location of required resources for using the CUDA toolkit with the NVIDIA libraries. Now the exciting part. Here first up, we use the git command to clone the Mixtral offloading repo from GitHub. This repo contains the code related to the Mixtral offloading technique that we discussed earlier in the video. Then we change the directory to the downloaded Mixtral offloading directory. Plus we install the required packages listed in this requirements.txt. As next step, we use the Hugging Face command line interface tool to download this specific Mixtral model, this one. This path identifies the model directory on Hugging Face where the specific Mixtral 8x7 billion variant with offloading support resides. And lastly, we clear the output from this cell in Colab to keep the console clean and ready for the next step in our code. This particular cell might take a while, 4-5 minutes to execute, so be patient with that. Now, while this code runs, let's review the next code cell that we have. Now, in this part of our code, we will continue setting up our environment and load further set of necessary resources for using a quantized Mixtral model for inference on Colab. Over here, first of all, we import the sys module, which provides various functions and variables that are used to manipulate different parts of the Python runtime environment. Then we add the Mixtral offloading directory to the Python search path using this sys module. Thereafter, we import torch library for deep learning operations along with the functional API, which is this. Thereafter, we are importing base quantize config, which is this, from the half quadratic quantization or HQQ core quantize module. Thereafter, we import screenshot download function. This function allows downloading specific versions of models from Hugging Face Model Hub. Then we import the tranche function. This function creates a progress bar for iterating through loops, providing visual feedback during execution. Thereafter, we import the autoconfig and autotokenizer classes from the transformers library. These classes allow loading pre-trained model configurations and tokenizers from Hugging Face Model Hub. Then comes logging module from the transformers library and assign it to HF logging alias. This model provides logging functionalities for the transformers library. And finally, we import the offload config, quant config, build model classes from the src build model module within our project directory. These functions are responsible for building the quantized Mixtral model with offloading capabilities. For your further reading, I have added these comments that further explain functionalities of these three classes. So let me execute this code cell as well. Now in this next section, we are going to initialize our Mixtral model. Within this, first of all, we declare our inputs, which are these. Within this, model name defines the base architecture of the Mixtral model. Quantized model name basically specifies the pre-trained optimized version with quantization, and the state path points to the directory containing the model's weights data. Basically, these guys are already downloaded into our runtime as part of this step number 1. Over here, we are just declaring them into these 3 objects. All right, next comes loading configuration and device. Within this, let's first discuss config. This retrieves the configuration options of the quantized model, including the number of layers and experts. Then comes device. This sets the target hardware for running the model. We are setting it to CUDA, which means we are specifying GPU as our hardware. Now, in this particular part, we are configuring our offloading. Basically, we specify how many expert models per layer get offloaded off the GPU to the cheaper memory. Default is 4. You may also adjust it to 5 for limited GPU memory. We'll keep it to 4. Now, with this offload config, we define the memory allocation for different parts of the model. Within this, we have these bunch of parameters. First is main size, which is memory for essential tasks. Then offload size, which is the memory dedicated to offloaded expert modules. And then we have buffer size, which is additional buffer memory for managing offloading. All right, for setting the quantization parameters, we have these attention config and feed forward config. These define the quantization setting for different parts of the model. Both of them have these bunch of 4 parameters. N bits, which is the number of bits used to represent weights, 4 for attention and 2 for feed forward. Group size, which is grouping strategy for quantization. Quant 0 and quant scale enable specific quantization techniques. As last step here, we have a quant config, which combines the individual configuration for attention and feed forward layers. And finally, we are building the model with this next line of code. Here, this build model function takes all the configurations, device and weights data to assemble the complete Mixtral model with offloading capabilities. Now let's run this cell and thereby prepare the Mixtral model for efficient inference in this Colab environment by allocating memory, configuring offloading, and finally building the complete model ready to run on the GPU. Alright, with this we have come to the last step. You know what that is? It's to perform inference with our Mixtral model. Let's do that now. So over here we are importing text streamer from transformer. It's a tool for streaming text generation, making it efficient for long conversations. Thereafter we define our tokenizer and streamer. With this tokenizer we load the model's tokenizer, which converts text into numeric tokens for the model to understand. Streamer creates a streamer object configured for smooth conversation flow. Thereafter, to have a conversation with the model, we have this conversation loop over here. It's basically an infinite loop that keeps the conversation going until interrupted. Within this loop, first of all, we are prompting the user to enter their message, basically the prompt against which the text is to be generated. Next comes tokenizing the user input. Basically, in this particular part, we create a dictionary representing the user's message with a user role. And we also use the tokenizer to convert the user's input into numeric tokens and send them to the GPU for processing. Then comes attention mask, which checks if it's the first part of the conversation. If so, it creates an attention mask that gives equal importance to all words. Else, if it's not the first part of the conversation, then it creates an attention mask that focuses on both the input and recent conversation history. Finally comes generation of response from Mixtral, which is happening through this model.generate, which calls the model's generate function with various parameters. Here I have also given a bit of explanation of all of these parameters, what they are and what they do. And finally, once the generation part is done, towards the end we have the update conversation state with the sequence and past key values. And because we are still inside of this loop, the conversation continues and the loop keeps running till the time we sort of interrupt this cell. Now let's run this cell. Alright, our Mixtral 8x7 billion model is now ready for inference. Let's have some fun with this mighty model now. I'm currently based out of Delhi and it's extreme winter in Delhi right now. How about getting a few lines written on the winters in Delhi from the perspective of a lazy boy? Let's see what we get. By the way guys, while you may find the text generation part a bit slow on this Mixtral model with offloading, but remember that it's still a mighty powerful model that's at work. There's a world of possibilities in the form of GenAI applications that you may build on top of this text generation functionality, be it a code writer, chatbot, personal assistant, etc. Mixtral is an open source model and you can absolutely build your GenAI applications on top of this. So what are you gonna build with this functionality? Do let me know in the comment section. So this is what the model has returned to us. In Delhi's winter I lie, a lazy boy with dreams in his eye. The cold air whispers, stay inside. Let the world outside pass by. It looks like a polished piece of work. Towards the end it says, and so the winter it goes on, a season long, never quite gone, but in my heart it's truly one, a lazy boy's delight, pure and undone. This truly sums up the winter for me for sure. Now let's try out another prompt over here, which is this. Create a news headline from the future 50 years that shocks the world. Let's see what the model says. So it says, scientists discover 100% renewable energy solution, ending fossil fuel era. This truly sounds like a news that will shock the world. Alright, next up, let's try writing some code with the help of Mixtral model. For that, I'll first interrupt execution. Now let's rerun it. Okay, this is what I'm gonna say. My prompt is, write a simple Python code to find the factorial of a number. Just give me the code, nothing else. Let's see what we get. Alright, the model has written the code for computing factorial of a number in Python. It sounds like right, but still let's test it once. Just copy it. Okay, I'll just paste it. Let's say 3 and we are getting 6. So that sounds clean. Guys, do share your experience of prompting the Mixtral model and what is your opinion on the performance. Will be interesting to hear what you think. So that's all we had for you in this video, guys. How was your experience performing this hands-on? Do let us know in the comment section below. Also, if you got stuck somewhere or faced any challenge, again, type in your query below and we'll get back to you. For more such GenAI hands-on videos, subscribe to our channel Happy learning to you. Bye.